Hi guys, this is Mr. Urrego, and today we're evaluating logarithms. Now, the idea is to evaluate logarithms without calculator, just our brains, nothing else, okay? No calculators. I'm going to show you the basic steps and how the process works, and then from there we get into much harder problems. Radicals towards the end, so wait for the radicals. They're interesting, let's put it like that. Alright, first one we're going to do is, let's start with this, log on base 2 of 8. The idea is to evaluate, meaning how much is the answer of this, okay? So how it works is the following. Normally I put a variable there to find out, to help me. So let's say that that's going to be equal to x and we're going to find the value of x, okay? So this is our logarithm. The idea is to rewrite this as an exponential, okay? As an exponential. How is an exponential? Here we go. So what we do is we take our base. By the way, this number is our base, this is our argument, and this is our solution, our answer, our logarithm, our exponent. You know, basically this is our answer. So I'm going to rewrite this. Base, argument. Those are the two most important ones. So I'm going to write that as an exponential. I take my base, raise it to my answer, equals to my argument. Again, base to the answer equals my argument. So this as an exponential is going to be 2 to the x equals 8. So the question is, every time we're working with the logarithms, we're thinking in exponents, okay? Because my answer is an exponent. So the idea is, to what exponent I raise the 2 in order for me to get 8. So the easiest way, this is a simple one because the answer is 3. But the idea is to learn a process. We learn a process, we can solve anything that I want. So I take always, I want to have the same base on both sides. I have a base 2 right now, but I have an 8 right now. I want a base 2, so I want to break that 8. I bring the 8 and I'll break it down. 4 times 2, 2 times 2. Okay? That means 8 is the same as 2 to the third power. So I'm going to replace that 8. So I keep the 2 to the x and I'll replace the 8, which is 2 cubed. Now, if my bases are the same, then my exponents are the same, are equal. Therefore, my answer is x equals 3. And that's my answer. So this is the process that I'm going to follow to do any type of logarithms. I'm evaluating. Again, if you notice, I didn't use a calculator. Okay? And that's an easy one. But we always want to break those numbers in order for me to get the same base. As soon as I get the same base, my exponents are the same, or equal. So my answer here is 3. Log on base 2 of 8 equals 3. 2 to the third equals 8. Okay? Let's play around with that 8. So let's say that I have a log on base 2 of 1 over 8. Okay? How much is that equal to? Same idea. I break the 8 and I rewrite that as an exponential. So let's say that I'm going to have an x right here, and I'll have 2 to the x equals 1 over 8. Same idea. I want to break the 8. So the 8 is 2 to the third power because I already have it. So 2 to the x equals 1 over 2 to the third power. And now I have the same base, but this base is on the denominator. I need to bring it to the top. Therefore, if I want to bring that power to the top, my exponent will change. So I'll have 2 to the x equals 2 to the third, positive on the bottom. As soon as it goes to the numerator, it changes the sign. Please check this video on the description for all my exponential. I explain all the properties of exponents. Go over it, make sure. Okay, so again, that went up to the numerator, and now my bases are the same. If the bases are the same, exponents are the same. Therefore, my x equals to -3. So log on base 2 of 1/8 equals -3. Now let's apply all what we learned already. Okay, that's the idea. Those are the basic steps. So let's find out how much is log on base 5 of 25. 5 to the x equals 25. 5 to the x equals 25. 25 is the same as 5 times 5. So therefore, 25 is the same as 5 squared. Bases are the same. Exponents are equal. Therefore, log base of 5. Log on base 5 of 25 equals to 2. And that's my answer. Let's move the 25 to the bottom. Log base 5 of 1 over 25. How much is that? Same idea. My base to the exponent, 5 to the x, equals my argument. 25 is 1 over 5 squared. Okay? Five squared. That 5 has to move to the top. Negative exponent, if it's positive on the bottom, it becomes negative on the top. If the bases are the same, x equals negative 2. So log base 5 of 1 over 25 equals to negative 2. Now keep that in mind. When you have a fraction in your argument, we see that we're going to get a negative number. Okay? Let's flip that. Instead of the base, let's flip those two. Log on base 25 of 5. How much is this equal to? My base is bigger than my argument. Therefore, I'm going to have some kind of fraction. Remember, okay? 25 to the x equals 5. Base, right? That's how we write it. I got to break the 25, which is 5 squared. I got to put an exponent over here. Power over power. You see that? Bases are the same, therefore my exponents are the same. 2x equals 1 divided by 2 divided by 2. X equals 1/2. So every time my base is bigger than my argument, I'm getting somehow a fraction. How come? Because that's 1/2 is square root. Alright? And that's my answer, 1/2. Last one. Let's flip that. Okay? Instead of 5, let's do 1 over 5. So log on base 25 of 1 over 5 is equal to what? 25 to the x power equals 1 over 5. 25 is 5 squared to the x equals, that goes on the top, 5 to the negative first. 5, 2x, 5, negative 1. Base is the same. 2x equals negative 1. Hold on. Divided by 2, x equals negative 1/2. So it's a fraction because my base is bigger than my argument. And it's negative because now I'm getting a fraction in my argument. Alright? So that's the same idea all the time. Alright? Let's get into another one. Now let's learn a basic property of logarithms. So if I have log on base 7 of 7, how much is that? 7 to the x equals 7. You probably know already the answer, right? Excellent. 7 to the x equals 7. What am I exponent? If there's no exponent, you have a 1. Bases are the same. How much is the x? So log on base 7 or 7 equals 1. Interesting. Let's change the base and see if it's going to happen again. Log base 3 of 3. What's going to happen? 3 to the x equals 3. 3 to the x equals 3. What's my exponent? Base is the same. Exponents are equal. 1. So, long story short, if the base on the argument are equal, these two are equal, my answer is 1. What about this one? Okay. Log on base 3 of 1 equals what? 3 to the x equals 1. Now what? What do I do? Let's think. What number do I need to raise the 3 in order to my answer to be 1? That's right, proper exponents. Link in the description. Any number to the 0 power is 1. Therefore, my x equals 0. In my case, log on base 3 of 1 equals x. My answer is 0. So every time I'm looking for the log of any base, does not matter, of 1, my answer will be 0. Example. Log base 5 of 1. 5 to the x equals 1. 5 to the x equals 1. What do I need to raise the 5 in order to get the answer? Yes, it has to be 0. 5 to the 0 equals 1. So my answer here is 0. Now let's talk about inverse properties. Log of base 7 of 7 to the x power. Okay? What's that equal to? So basically, when my base and my argument are the same, we said that that's going to be equal to 1. In our case, they cancel each other. My answer is going to be x. Log of base 3 of base 3. This by itself is 1. Remember, same base, same argument. So whatever exponent I put here, my answer is going to be my exponent. My answer is going to be my exponent. What about the other case? 3 to the, this is my exponent. 3 to the log on base 3 of x. If this base and this base are equal, they cancel each other. My answer is x. So my argument will be my answer. Another one. 5 to the log on base 5. Right there, I know they're going to cancel out. So whatever I put here is going to be my answer. Let's talk about common logarithms. All right. If you notice in your calculators, you have a key that it says log with no base. When there's no base, that means your base is base 10. That's called common logarithm. All the properties that we learned already apply to this. So this is what we use in calculator. So let's say that I have log of 10. But what is this? Remember, there's no base, then I have log on base 10 of 10, which is 1. Okay? Inverse properties. If I have 10 to the log of x, if you notice, I didn't put any base on the log. That means I have log, no base is a base 10. Okay? Of x. This and this will cancel out, and my answer will be the argument. Alright? Okay. Let's say that I have log of 100. How much is log of 100? What is my base? Base 10. So having this is having this. And remember, 100 is the same as 10 squared. So log on base 10, 100 is 10 squared. What's going to happen with this base and this base? They cancel out. My answer is 2. Okay? Let's play around a little bit more. Let's say that I have log of 1,000. I don't need to put the base. Base 10. So let's break the 1,000 into 10 to the third power. So log of 10 to the third power. Technically I have a base 10, which cancels this. My answer is 3. Okay? Log of 1 over 100. Same idea. Okay? Log of 1 over 10 to the second power. Log of 10 to the negative 2 power. Right? You notice I didn't replace it. I didn't rewrite it as an exponential. I just kept working with the 100. 1 over 100 is 10 to the second power. I move it to the top, which becomes negative exponent. And now, if I put a base, you know that this base and that's going to cancel out. My answer is negative 2. So these are basic properties that we need to learn in order for us to work with logarithms. Now, last but not least, let's talk about natural log, natural logarithms. These are very famous, okay? And this is another key that you're going to find out in your calculator. And in your calculator, you're going to see ln, all right? And on top of ln, you're going to see an e. This is the exponential, which is a number. It's 2.71 something something. Is a number like pi, all right? ln stands for natural log, natural logarithm. Now, the idea is the following. Natural log and e are inverse to each other, all right? And you'll graph later on, which you can see a link on the description as well for those graphs. Those are inverse to each other. But now, why ln? Just to make it simple. ln is nothing else than log on base e. ln is the same as log on base e. Okay, but instead of writing log on base e, we write ln. Now let's do this one. ln of e. How much is ln of e? 1. Right, but why 1? Remember, ln is the same as log on base e. So let's replace this. Log on base e of e. If my base and my argument are equal, then my answer is 1. Okay? So we need to get familiar with ln. Inverse property. E to the ln of 7. What's going to happen? E to log of base e of 7. Remember, ln is the same as log on base e. Therefore, my answer is 7. And we're just playing around with those properties. What about ln of ln of 1? My answer is 0, right? Instead of ln, let me write log on base e of 1, which is e to the 0 equals 1. Is that right? So any log of 1, well, my answer will be 0 all the time. 1 over e to the 6th power. What's the idea? How much is this? I got to bring that e to the top. ln of e to the negative 6th power. Remember, these are inverse to each other, therefore my answer is negative 6. Okay? ln of e to the 5x. What's my answer? ln and e are inverse to each other, therefore my answer is 5x. So don't get confused because the ln. Most of the times the problems are really simple. Okay? And as promised, let's do one with radical or two with radicals. Let's work on that. Let's say that I have log on base 2 of 1 over square root 32. Okay? The idea is the same thing. Let's rewrite this. Let's put an x on the other side. Let's rewrite that. So I'll have 2 to the x power equals 1 over square root 32. I gotta break that 32. 32. 8 times 4. 4 times 2. 2 times 2. 2 times 2. How many 2's I have? 5 2's. So 32 is the same as 2 to the 5th power. Okay? Let's rewrite that. 2 to the x is the same as 1 over square root of 2 to the 5th power. I need to rewrite this as a rational exponent. Okay? 2 to the x is the same as 1 over rational exponent. I bring my power and my index will divide my exponent. Okay? My index divides my exponent. And that's how I rewrite a radical as a rational exponent. Excellent. Now I'm going to bring that to the top. 2 to the x is the same as 2 to the negative 5 over 2. Change the sign. Bases are the same. X equals. If the bases are the same, exponents are equal. My answer for all this, original problem, log on base 2 of this is equal to negative 5 over 2. Okay? Now let's do one more. By the way, guys, if you haven't subscribed to the channel, subscribe to the channel, like the video. Okay? There's going to be a lot more. Same as this. Alright? Good material for you guys. So we learn a lot of math. Log on base 3 of 1 over square root of 81. Same idea. Pause the video. Try to solve it. Be back in 30 seconds. 30 seconds. Equal to x, right? I hope you work it out. 3 to the x equals 1 over square root of 81. Right? Break the 81. 9, 9, 3, 3, 3, 3. How many 3's? 81 is the same as 3 to the 4th power. let's rewrite this whole thing. 3 to the x equals 1 over square root of 3 to the 4th power. Interesting. Oh, come on. Yeah, I didn't notice the 81. That's an easy one, though. But that's fine. Okay, let's rewrite this as a rational exponent. So I have 3 to the x power equals 1 over rational exponent. I bring my power, my index divides my power. Therefore, I have 3 to the x equals 1 over 4 divided by 2. And actually, that came out. Okay. Now, positive exponent, bring it to the top. And I'm going to have 3 to negative 2. If the base is the same, my exponents are the same. Therefore, log on base 3 of 1 over square root of 81, which is 9, equals to negative 2. Alright guys, and that's it for today. Next videos are going to be an exponential and logarithmic. Check out those graphs. Like the video, subscribe to the channel. I'll see you in the next one. Thank you for watching. Bye-bye.